Hey Data Skeptic listeners, quick announcement before we formally begin the show. We're going to host a members-only video hangout Sunday, July 28th, 11 a.m. Pacific time. Somewhere between now and then, I'm going to send all the members an email. Actually, I'm going to send you a Google Calendar invite link, so be on the lookout for that. It'll contain details about how to connect. So save the date. I'm going to use that opportunity to share with you guys in advance the new theme, because we're going to turn over to our next season in a little bit here, winding down our natural language processing theme, which frankly could have gone on and on. If there's one takeaway from this season, it's, wow, this field is exploding right now. So perhaps we'll be back. NLP2, he's back, and this time he's pissed. Anyway, I'm going to do some giveaways. I'll preview the next season. And if you have any questions, send them in advance to kyle@dataskeptic.com. If turnout is good, we'll make it regular. And if you guys are interested in some of the things we're building behind the scenes, I'd love to do some deep dives on the technology if anybody's interested in observing our process with that resolution. So I hope you'll all join us. Hit me up if you have any problems with that or don't see my invite or whatever. But save the date. Sunday, July 28th, 2019, 11 a.m. All right, well, today, Linda, I want to talk to you about catastrophic forgetting. And maybe first we should talk about the context of memory with a couple examples. So what did you have for breakfast today?
What did I have for breakfast? Let me think. Just for context, this is the end of the day. So Kyle is asking me what I did 12 hours ago.
Right.
Okay, let me think. Oh, I had a slice of my homemade pumpkin bread with farmer's cheese, and then I had a salad.
All right. Interesting choices. How about last year, October 14th, 2018? What did you have for breakfast that day?
I couldn't say.
What about last year on your birthday?
I don't know still. It wasn't a special breakfast, so I don't know.
Or what about on our wedding day?
What I have for breakfast on our wedding day?
Yeah.
I mean, that was a special day. However, I think I just crammed whatever food down and then just tried to get ready because we did hair, makeup, and then did all this prep work. So I don't remember still.
Do you need that information? Is it useful to you in any way?
Nope, not to me.
So in that regard, I would agree. Remembering today's breakfast could be important, right? Like what if you get sick? Then you want to trace it back to maybe food poisoning. But that information doesn't have any value after a while. So it's good we forget it. We make room for that kind of stuff. However, what if you forgot some skill, like how to ride a bike? What do you think? Can you forget how to ride a bike?
If I forget, well, I think you can. Yeah, I think you could forget.
But without having a brain injury, you just don't ride for a long time. You're not going to get on and fall over, right?
I don't know. People say that, but I just never met anyone to disprove it. But that being said, I don't go around asking people, have you forgotten how to ride a bike?
That sounds really creepy.
Well, the questions you're asking are creepy.
All right, well, let's get even creepier then, because we're starting to describe neural networks with some of this context. You know, a deep learning system that uses neural networks is just a connection of millions of, they're just very small mathematical operations. And if you have a lot of them and they're connected enough and you train them for long enough, they can do striking things, right?
Well, I think that's what you've told me, so I'll have to agree.
But you've seen it in your own life, haven't you?
Well, I don't know. What uses neural networks that amazes me?
Photo recognition?
That's amazing, and I love technology, but it doesn't amaze me.
How about automated closed captioning?
I actually use closed captioning, and I often find that they choose the wrong words and there are grammatical errors.
Well, first of all, you don't know if that was algorithmic or if that was human-based, because the ones I see look like human errors. The algorithms are on these tasks performing at or above human level in most of the sort of academic tests of things. So I think you should give a little bit more credit to the accuracy. But aren't you glad to have the closed captioning?
Yeah, I'm grateful. But I have a question. How come when I say, hello, Google, it never knows what I'm saying?
Well, it does the greeting for you, right?
Yeah.
Do you mean it doesn't hear the next part or it doesn't interpret it?
Yeah, like whatever phrase I'll say. Like, for example, Yoshi was recently diagnosed with bacteria infection. So when I Googled Pastorella, they didn't seem to know what I was Googling, or verbally saying, rather.
That's because that's not a word that the system is highly adapted towards. It's probably not even in their training data. It's sort of To my tongue, it feels a bit unusual. Like the only word similar I can think of is sarsaparilla, but it's sort of like a cadence that doesn't feel modern. Would you agree? Or it feels overly technical or overly Latin or something like that.
I mean, I don't know. It's not something I use on a daily basis, this word.
Right.
But why doesn't it know what I'm saying? You're just saying it wasn't part of the training data?
Well, it doesn't necessarily have to be, because what you want out of that network is that each of the deep learning parts of it are learning something different. So at the very most shallow layers, it's learning the phonemes, or it's learning frequency information. And at the upper layers, it's learning how to combine, those into syllables, into words, and stuff like that. And at the highest level, also recognize like, oh, that's the end of a sentence versus a continuation. So you have learning at all levels, and they all are interdependent. People who are building that technology, first of all, if they want to take it to market in some way, then they really need to target the most used cases. So that's like the 1,000 most common words, or probably the 10,000 most common words or something like that. And if it does really well on those, it's worth taking to market, because that's going to cover 90% of cases. And even if the audio interpretation's not very good, like, it's getting the phonemes wrong, sometimes that's good enough that something like a spell checker can take it the rest of the way there. So that spell checker is probably highly attuned to, common English and not medical terms. So it's not that the word has to appear in the training set, although that certainly would have helped. But, it's just that it's a little rarer, and it doesn't seem to fit a common pattern for words.
But you're saying they take it to market when it's 90% correct, but are they validating that number? Because I often find when I use it, at least say 40% of the time, I feel like it doesn't Google or search what I want exactly.
So 90% is just a number I made up, for starters, but you feel that it fails more often than you would hope for a release. Is that what you're saying?
Yeah.
Okay. I mean, I can't say you're wrong, because at the root of it, that is a personal opinion. Maybe you want absolute perfection. I want something that barely works. It's, it's a personal thing, and you're thinking it's a little low. In that regard, I think, one, we don't know where the fault is. So, your device itself could have a weak microphone or something going on like that, where even the best algorithm is starting from a weak signal. I find that hard to believe, but you got to give that a maybe, especially when you're on the speaker. But after that, it could be that they want to do the processing local, which is called edge compute, meaning in your phone, rather than transmitting the audio file to the cloud, processing it there, and sending the result back. You want to minimize on that round trip sometimes because of the delay and the bandwidth, but keeping the computation local or at the edge, then you have this other problem of you're going to burn the battery, and you have to make the model fit on the edge device. And that model, it can be large, like, 16 gigabytes, and your device might not have that available, or you don't want to swap that in and out of memory. So to do the edge compute, you take a really weakened version of the algorithm or of the model, and you send the like weak version to the edge, and it doesn't perform as well. So that could be another reason too.
Okay. Well, you gave me a lot of things to noodle on. Thank you.
Well, I want to get into the training of these things and get back to catastrophic forgetting. So catastrophic forgetting is the case where a machine learning model, in this case almost always a deep learning neural network, it saw some information or it saw some data from which it could have learned a pattern. And if it trains a lot more and sees more examples, those older examples fade with time. Just like your memory of what you had for breakfast fades with time, there's sort of a bias towards more recent training data in neural networks.
In our general day-to-day lives, I think that we're biased to remembering the most recent thing, probably because things are constantly changing. Mm-hmm. So the best way to base our learnings is on the most recent.
Yeah, I think that's very accurate for us as people. And we did that somewhat consciously, almost like establishing a finite time horizon. We're going to look back. But you're giving a little bit too much credit to the algorithms here. The reason they bias more towards the more recent data is sort of a consequence of design. If it's a feature, then it's an accidental feature. So it works like this. Imagine if you are at a big dashboard in some like control panel factory setting, and there's like 10,000 knobs in front of you. And your job is to tweak all those knobs. Different situations are going to run in front of you on an assembly line. You'll tweak the knobs until you're happy, and then it moves down the assembly line to the next example. So that's what machine learning training kind of works like. You show the model a bunch of examples, and you say, tweak all your knobs to find get as close as you can to predicting what I'm showing you. And once we feel like we're good there, we'll move on to other examples, and we'll have the whole process over and over again.
So it sounds like you're saying there's something where like tweaking, and you keep tweaking till it gets closer.
Yeah, the tweaking is the learning process. If all the knobs were in the perfect places, then you wouldn't have to adjust the machine.
Yeah.
But the knobs are not in the perfect places to begin with. They start off random, and machine learning is figuring out the right way to tweak and revise them to get the right settings for each of those parameters.
Okay, so you're refining the results.
Right.
Is that standard?
The procedure I described applies to almost all machine learning, yes.
No, I mean using machine learning. Is that standard?
Oh, I mean, depends on the problem, but yeah, more and more machine learning is being used in pretty much every area of life.
Good to know. Do we as humans use machine learning?
Well, that's a bit too philosophical for Data Skeptic. Do we use it? Well, you have a phone that does voice-to-text recognition, which uses machine learning software, or uses a model that was built via machine learning. So in that context, as tool wielders, yes, human beings use machine learning. We also use it, on the chalkboard if we're doing, academic stuff. And one could build an esoteric argument that we use it in our brains, because what are they but biological machines? And they are capable of learning. So they're implementing something Pedro Domingos calls the master algorithm.
But if it's us using it in our brain, is it not a machine? So you think we're a machine?
If you prick me, dost thou not bleed? If you feed me code, do I not compute? I don't understand the question.
So are we a machine or not?
Yeah.
I'm trying to figure this out. So you think we're a machine.
Of course.
But if someone were to disagree and say we're not a machine, then it would probably just be called human learning, right?
If you start from the premise that humans are not machines, then no, because it still doesn't mean we don't follow the same mechanism of learning.
It still doesn't mean we don't follow. So we would follow the same mechanism of learning is what you're implying.
You cannot exclude it.
It's possible.
Well, I mean, the alternative is to believe that humans are magic, right?
Well, that's not the only alternative. That is a theory.
What's the other alternative?
I could make something up. We're aliens or something.
Essentially, the claim is there anything special that the human brain can do that couldn't be replicated in a machine? And there's not really any good argument to say yes.
So your question was, is there anything that a human can do that cannot be replicated in a machine?
Yeah.
Okay.
You know the song, anything you can do, machines can do better.
Well, that's your song.
Yeah.
Well, they haven't proven it out yet, 100%.
Fair enough. No, fair enough.
Okay, that was all.
All right. So, catastrophic forgetting. Let's say you're a security guard at like a video game retail store, okay? It's going to be a little silly. You with me?
Okay, a video game retail store.
Yeah. In the first level, you start playing and you notice every time somebody comes in and has this like red X on their jacket, they always steal something. So you keep an eye on them and you catch them and you get points by finding the thieves. And the thieves are easy to identify because they have the red X logo.
Thieves have a red X.
Yep. Now in level 2, it changes and you have to find a different pattern of who's stealing, or maybe you have to watch more carefully, but you don't see any more red X's.
Okay.
And then, maybe later in the game you find some other logos, like another gang comes in and they have a spider logo and, they steal things 50% of the time or stuff like that. And then you keep playing this game for a long, long time and you get to level 100 and suddenly comes back a person with a red X on their jacket. What do you assume?
What comes back?
A non-player character enters the store wearing a red X.
Well, I don't know. You said it started off that they were thieves.
Yes.
And then it said they weren't.
No, then you didn't see any
So
of
I
them.
don't
They
know.
were just absent.
Well, I guess the best case is just I assume they're a thief because that'll protect me.
See, that's the problem with you. They were gone for 99 levels, and you can't just assume they've done their time and they've come out and straightened out. You're what's wrong with society, Linda.
I know, but that's human
No,
nature.
but
Just want to protect ourselves.
for the video game, you're exactly right. That would be the right cause of action because the last time you saw them, you verified, oh, this type of character always steals from the store. It's my job to arrest them so I get my points as a security guard. And it's because you remember back to the first level. If you had focused only on training more recent examples, you might have forgotten 100 levels ago. And in that case, catastrophically not remembered that red X was an indicator for criminal.
What do you mean by forgotten catastrophically?
Oh, catastrophically because it's to your detriment. If you had remembered, you would have gotten more points.
Why would I get more points?
Because you could catch a thief faster.
I see. Okay.
It should go without saying that you lose points if you click on an innocent person too, right? So that's the game.
Ah.
So catastrophic forgetting is something humans rarely do. If there's something important to you, like look both ways before crossing the street, or remembering that the oven is hot and you don't want to touch it, these are things we're very good at remembering, right?
Yes.
Or even long-term things like what's something that you might be hurt by if you forgot it?
My cell phone.
Yeah, or your bank PIN number that you don't necessarily use all the time.
Oh my gosh, that happened to me. I had to reset it, but you have to either call or go into the bank. It's such an inconvenience.
All right, so you did catastrophically forget something.
Yeah, and it was so annoying.
Had you continued to train on that, for example, making yourself recite it every day, it's more likely that would have been in your memory and you would have more quickly been able to recall it.
I know. I just wrote it down.
So the machine learning that I did many, many years ago when I was getting started was all very sequential. So even if you looked at time series data or things that happen in series, you kind of look at the last time period and the current time period. And, sometimes maybe you'd look a few back or you want to find a nice Bayesian way of representing all your knowledge, but you don't look at the whole history and you don't look too far into the past. And so there's been a lot of work over the years of people figuring out smarter ways to look further back. But there's still this problem that you cannot expect to look at the whole history of your data set in every go. So you have to find some way to know what's important and remember it. And things like the attention mechanism we've talked about on the show are ways. But this is an open area in machine learning because we as humans don't seem to have this catastrophic forgetting property, but machine learning still definitely does.
Wow. Can you give me some more examples of catastrophic forgetting? You mean just forgetting absolutely, like having no past history?
Well, let me give you a more formal definition. So if you're studying something sequential like natural language processing, ideas from earlier in a conversation are relevant later. Those are all things that we're good at not forgetting. But machine learning has a problem with that because most natural language processing is looking back like 5 to 10 words or, actually, I don't know what the current state of the art is in the research. Maybe they go back 30 words, but there's some finite number of words that those algorithms will look back into the past. And think about yourself if you had amnesia and suddenly you were in a conversation, but you only remember the last 25 words. It would be, you might be able to carry on that conversation. You might be able to order at a restaurant, but to talk like we've been talking tonight, it would be impossible, right?
I don't know. Sometimes I do forget, so.
So that would be the best human way to try and anthropomorphize this and experience catastrophic forgetting. It's the case where you saw some information that would have been helpful that happened earlier, but you just can't remember it. It's like there's a blocker and you can't recall it. When I describe it that way, it sounds like you're very conscious of it. Like you're like, oh, what was the name of this person? I've met them before. I know their face. I met them at this conference, but what is their name? I wish I could remember it so I can acknowledge them. Because I know that information was there in the past, and I could use it now, but I just can't remember it. Now, the machine learning side, it's not as remorseful because it isn't cognizant that it's lost some information. So the analogy breaks down in that way. But basically, it's like you're training on a sequence of data. And if there was something important or useful at the beginning where the algorithm was still kind of getting its sea legs, that information might not be as present in the later data because it tends to learn most and be most influenced by the most recent examples it's seen.
Yes, because the most recent is most likely the most helpful.
From a human's point of view, yes. But that part of the analogy breaks down a little bit because it's not that the algorithm is putting a value per se. I mean, I guess implicitly it does, but it's not explicit like you're making it. The algorithm wasn't designed in such a way to deliberately forget. It just lacks the mechanism to remember in a smart way.
Remember in a smart way. You mean like balance, not the recency. What is it? Bias. Recency bias.
Yeah, the ability to recognize what's important and to store it in some easy to recall way. That's the challenge for AI, and it's something that the attention mechanism is trying to do. And we've made a lot of progress there, but I think there's still more innovation to be had. So interesting topics to be following.
Great.
Anyway, thanks as always for joining me, Linda.
Thank you.